Hi guys, welcome back to Piping, Welding and DT channel. So this is an example of as-building. So I will show you how to as-build isometric drawing. Okay. So we have an isometric here, and there are different orientation, of course, and you see this cloud. So this is a cloud, so it means they have changing of an isometric. So there are new isometric, there are changing orientation or additional joint, additional supports. Okay, they have something like that. So this is an example of as-built-in or as-built drawing. Okay, during line checking, okay, during line checking, if you are line check in this site, okay, of course in the site, and if you see there are some additional joint, they have no here in the isometric drawing. Just put the remarks here in isometric drawing, and then if you see, of course they are changing orientation. Just draw temporary here using pencil. Okay, and during line checking, you see they have additional supports, of course, additional fittings, because there are some additional fittings. They have some hindrance or support that coming up from this orientation based on isometric drawing. So this is the example of as-built. So this cloud, this line is an old drawing. It means during line checking, you see this orientation. So this is in the site, this is the orientation, and this on the isometric, this is the orientation. So this is the old and new orientation. Okay, so if you see this old orientation based on northing, so the north is going here based on this isometric drawing. So this is going to north, down, going to south, going to east, going to south, and down, going to south, and down. So in the field, so this is the new orientation. Okay, from starting here. So from starting here, so this is the new drawing. Of course, this is, we will start here. Okay. So from this cloud, so this is going to north, and of course this is going to north. You see this all the orientation, they have no going to west. So this is going to west. So of course all joint here in the all the orientation of all joint, they are also changing the joint number. Okay, so we will start here. So this is a joint This is a joint 23. Okay, and they have on this drawing they have 23A. Okay, they have a 22. This is a 43A. This is a new joint. 44A new joint, 45A, 46A. So they have a too much additional joints, and of course additional fittings. 46A, so this is a new joint. 35, 34, this is old joint. All that they have additional letter A. So this is a 41A, 42A, so it means this is additional joint. There are additional fittings, changing orientation. Okay, and then after you make a drawing based on the field, you must put a note here. So this is the note. Just put the remarks in this ISO and put additional joint as built by. If you are an inspector, just put your name and of course your signature, and then put additional joint 42A, 43, something like that. Additional support 901A, 902A. So that is the way how to as built, and then go to engineering, and then signature and receive by engineering, and for construction. Okay, so this is if the inspector and also the engineering receive it and signature it, receive and forward it to construction. This is the new drawing and new revision drawing. Okay, so that's all for now, guys, and thanks for watching. So this is the way how to as-building isometric drawing, and bye bye, have a nice day, see you guys. Hi guys, welcome back to Piping, Welding and DT channel. So this is isometric drawing. Okay, this is for you and all new pipefitter. So this is the actual isometric drawing. Okay, so in this isometric drawing, first to be checked is the latest drawing. Okay, so how to check the latest drawing? So you must check the revision drawing. Okay, so in the revision drawing, you can see here in this table. So this is, we will check here in the revision drawing. Anyway, if you see this cloud, so this is a new revision drawing. So this is a new isometric drawing. Okay, so they have a line number. So this is the line number. I will zoom it. So this is the line number. This is the line number of the isometric drawing. Okay, and this is the revision. Okay, and we have a sheet number. So this is the sheet number. So always check this revision and the sheet number. So this is the design area, the unit. Okay, and we have also on this table, we will see it here, the design pressure. So the design pressure is here. So this is the design pressure, the operating pressure, test pressure, chemical treatment, insulation code, and DE. So you can see here in this table. So how many percent of ND? So let's say this is ND 5%, and painting code. So this is a painting code 21. So we have also in this isometric design temperature 90, and this is operating temperature, commissioning system, internal cleaning, tracing, and painting system. And also a line list, PNID number. So this is the PNID number. If you want to check this line in the PNID, check here what is number. You will find it in the PNID. So this is the PNID Pipefitter class. Okay. So all here in this table. Now, okay, this is the BOM. So this is the bill of materials. Okay, and this bill of materials, the type of materials here is the size, code, and the quantity. So this is the quantity, code, and the size. So size is 100. The fittings here, so 5. So this is 833 grade 6. So this is the pipe ASTM. Okay, fittings. So here is 90 and 45 degrees elbow and plunge. How many? Size, code, and the quantity. And also here is the cut pipe length, welded list. This is a weld list. So this line is this portion is for the erection materials. The gasket, instrument, supports, and also bolts list here. Okay, so this is the line to be fit up in the fabrication. So if you see this one, this is a field weld, this is a shop weld, supports. So if you see this arrow, so this is a flow direction. It means the service is going there. Okay, and also in this isometric, you see this shadow. So this is the important to be checked. If you are in the fabrication, check always this shadow, where going to be and where is the orientation. Okay, and this is the orientation going to north. Okay, so this is the isometric number, and this is the actual isometric. So this is for you, for all new pipefitter. Check the continuation, the easting, northing, and the elevation. This is the important in the field: easting, northing, and also the elevation. Continuation also, and they have also continuation here. So this is the spool number. How many spool? 1, 2, 3. So that one is the 3 spool. Okay. So a lot here you can learn here in the ISO basic, but this is only a basic knowledge and basic tutorial. We have more videos coming up for this, how to read the isometric drawing. Okay, so if you see these symbols, so this is a support, and they have also this hidden line is a trace line. Okay, tracing line. So this support is, they have a comment here, hold down support. So this detail to be checked in the other drawing, support details. So what type support is this? So this is guide, or this is pipe shoe. Okay, all to be checked in the support details. Okay, so that's all for now, guys, and thanks for watching, and have a nice day. Bye bye. God bless. Hi guys, hi to all my subscriber. So this is our new video, and if you can see, we have a numbering from this table. Okay, so that one is a different degrees. So we have 10 degrees, 20 degrees, 30 degrees, 40, 45, 50, 60, 70, 80, and 90 degrees. Okay, and these degrees, they have a different constant angle. So this formula for the constant angle is number one important in the piping works, or the pipefitter. If you have a different degree, or a spatial degree in elbow, you are using a spatial elbow like 30 degrees, 40, 60 degrees, like that. Okay, you can now compute it for the constant angle. So let example for this 10 degrees. Okay, we will compute this 10 degrees, and we will find it the constant angle. So 10 degrees, half of the 10 degrees is 5. Okay, and then tangent of 5, tangent of 5 equals, then multiply it to 1.5, multiply it to 38.1. So our answer for the 10 degrees, so this is the constant, so this is our answer. So 4.9, and our answer for this 4.9, this is our constant angle for 10 degrees, and if we round off it, this is 5 degrees. Okay, so that one is how to compute the any angle. Okay, you can use this formula if you have a 30 degrees elbow. You will find the takeoff. You will find the takeoff this 30-degree elbow, and for this the same formula, and you can compute now what is the total spool you are using. Okay, let's try again this 20 degrees. Half of 20 degrees, 10. So tangent of 10, multiply to 1.5, multiply to 38.1. So our answer is 10. Okay, so this is the constant angle of 20. So this is 10 degrees, and let's compute this 30 degrees, 45, and 60. So 30, 15, tangent of 15, multiply 1.5, multiply to 25.4. So this is our answer for the 30 degrees. $10.20. So let's try is the 45 degrees. 45 divided to 22.5. So this 22 tangent 22.5, multiply it to 1.5, multiply it to 25.4. So this is our answer is 15 point, for the 45 degrees is 15.78. Okay. So this is the formula if you are calculating the spool. If you have a 45 degrees elbow, just multiply this 15.78 to the diameter of 5. Okay, and then the answer, and then minus it to the total length of center to center of elbow and to center of 5 and elbow. Okay, so this is how to compute it. So this is the easy way to compute it, the constant angle. Okay, so please try it this all degrees in your home. Please compute this 50, 60, 70, 80 and 90. Okay, please compute this and example. Let's try and compute it in your home and example it if your answer is correct based on our formula. So thanks for watching, guys, and have a nice day. See you next time. Bye bye. Hi guys, welcome back to Piping, Welding and DT channel. So hello to all my subscriber, and this is we will talk about material specification. So let's start to CS. So what is CS? So CS is carbon steel. So start to the fittings. CS flange. So this is material specification. Okay, so carbon steel flange, this is A105, and this is a forging. Okay, forging. And we have also a plate. For the plate, we have a specification of A515 GR70. So this is for the plates. Next is SS. Okay, so SS is stainless steel. SS plans, we have A182 grade F304. Okay, so LTCS. So what is LTCS? So LTCS is low temp carbon steel. Okay, so this is LTS plans. For the LTCS plans, we have A350, A350 grade LF. So this is LF3. Okay, and AS. So AS alloy steel flange. So this is a specification of A182 GRF11. So this is the material, the typical material specification. Okay, carbon steel, stainless steel, LTCS, and alloy steel. Okay, And for the stainless steel, we have 304 and also a 316. Okay, what is the difference between that? 304 and 316. Okay, so we have in the SS304, they have 18 chrome and 8 nickel, where SS316, this is contains of molybdenum 2 to 3. So this is 2 to 3% for the SS316. Okay, that one is the difference between the SS304 and 316. And they have also a 3 SS321. So this is also a stainless steel, and they have the same chemical composition with SS304, but in addition they have a contains of the TI, which is this is stabilized for this, contains of TI. So that one is a 3 difference between the 304 and 316 and 321. So this is a common and typical material specification. This is only for the plants. Okay, so thanks for watching, guys, and have a nice day. Bye bye, see you next time.